This video covers Trig P.6 and Pre-Calc 1.5 notes. We're going to continue talking about functions today. We're going to continue to look at the domain and range of functions and looking at their graph to help us pull that information off of the graph. So if I asked you to look at the graph of y equals the square root of x plus 2, here is the graph. So I invite you to pause the video and take a second to plot this graph on your xy axis in your notes here. Okay, so looking at the graph, if I asked you to tell me the domain, I'm asking you to tell me what x values work. And then we can see that the graph is at a -2, and it's continuing off here and then in the positive direction. So the x values that are going to work for this graph would be the x values that are greater than or equal to -2. Again, if I put a -2 in here, I get the square root of 0. The square root of 0 exists. If I put anything that's smaller than a -2, for example, a -3 in here, then I get the square root of -1, and that's imaginary. So that's why it has to be numbers that are bigger than -2 or equal to -2. Now, if I ask you to tell me the y values that are working, so it's the y values that are working, notice that the graph is completely above the y-axis, the x-axis, so therefore all of these positive values for y would work. So in other words, y is greater than or equal to 0. And again, I think that the easiest way to find the domain and range is to look at the graph. So I invite you to use your graphing calculator when you are doing these problems. Okay, so the next example that I'm going to ask you to tell me the domain and range of, we don't have the equation for the function, we just have the graph. And one thing I want to make clear here, and my graph is just a little bit off, but this dot here is really right there at an x value of -1, and this open circle here is really at an x value of 4. So let's make sure we understand that first, and that was just because I drew it just a little bit off from where it's supposed to be. So I don't know the actual equation, so if I'm trying to find the domain, I'm going to ask you what x values work. So notice that this is my very leftmost x value, this is my very rightmost x value. So it's going from a -1 all the way over to a 4, but at 4 it's an open circle, at -1 it's a closed, and that makes a difference. It means it can be equal to -1, but not equal to 4. So the way that I would write this is that x values are between, so x is going to be greater than -1, but since it's a closed circle, it's also equal to, and x is going to be less than a +4, and since that's an open circle, it's going to be not equal to. So pay attention to dots versus open circles on your graph. It means that the graph goes all the way up to that number, but not equal to that number. The range, on the other hand, we're looking at the y values that work. So the very largest y value is up here at a 4, and the smallest y value comes all the way down here to a -3. And again, closed dot there, so I know that they're both going to be equal to. So our y values are going to be between, the smallest value is -3, largest value is a +4. So y is going to be greater than or equal to -3, but less than or equal to 4. And again, using our graph is a very, very convenient way of visualizing what x values and what y values work. Alright, let's get off the topic of domain and range a little bit and change functions here to finding the zeros of the graph. Remember, if I'm asking you to find the zeros of the graph, that means your graph or your equation is equal to 0. So we're going to change these to zeros, and now we're going to solve. And if that's a little too sloppy for you, you can write that as a 0 here. Now I have to remember how to solve a polynomial that starts out with a 3 or a coefficient other than 1 in front. And that method is the box method. You're going to have to factor it by asking yourself what multiplies to be -30, but adds to be a +1. So it multiplies to be -30, but adds to be +1. And I'm thinking a 6 and a 5, but I would have to have the 5 be negative. Again, the biggest mistake that students will make is they'll go and put these right in their sets of parentheses, but it's called the box method for a reason, because you have to make a box. And in the box, you're going to put in the first portion of the box, you put the first term that you're factoring, 3x squared. The last term would go in the last box. And then these two terms that you came up with, the 6 and negative 5, go in the boxes here, along with the coefficient. And so now you can go through and you can pull out the greatest common factor going across and going down. So going across, notice that we have an x in common. And going across here, the greatest common factor is a 2. And then because this was a positive 6, it means that that's a positive 2. So whatever the sign is here, will tell you what the sign is in between these two. And whatever the sign is here, will tell you what the sign is in between here. So I know there's going to be a minus in between there. So pulling out the greatest common factor going down this way, I can take out a 3x and 5, but again, it's really a negative 5 because that's a minus there. So this would factor out to be 3x minus 5 and x plus 2. I'm not sure if I did that correct. If I FOIL this, I should get right back to my original. So you may want to take the time to do a quick FOIL and make sure you can get that. That helps eliminate any mistakes you may make using this box method. But again, because this is equal to 0, you would want to set each of these factors individually equal to 0. And so here you would subtract 2 and get a negative 2. Here we would have to add 5 and then divide by 3. So I'd get x being equal to 5/3. So pay attention to what the problem is asking. It says to find the 0, so that's another way of saying solve, not just factor. And so since it was a degree 2 polynomial, I should get 2 answers, and I did get 2 answers. So if we take a look at this next one, again, if it asks me to find the zeros, just kind of draw a line here. If I set it equal to 0, you're going to get an equation that looks like this. So now we have to get rid of that radical before I can start to move things out from underneath it. So the way you undo a square root is you square both sides. So when I square both sides, I'm going to get 10 minus 2x on this side, and then squaring a 0 doesn't change anything. Now what I'm going to do is I'm going to actually move the x squared over just to make it positive. I could subtract 10 and then divide by negative 1, but then that's 2 steps that I have to do, and when I can really reduce it down to 1 step there. And then I've got to get rid of the squared, so the way I get rid of a squared is I take the square root. Now remember, degree 2 polynomial, so I should get 2 answers. So I have to remember to take the square root of 10 and get a plus or minus. Plus or minus the square root of 10. Usually where students will make a mistake on a problem like this is they will forget the plus or minus. Again, when you're solving an equation and you have to take the square root of the equation, make sure you consider both the positive and the negative answer. So the answer to this one would be plus or minus the square root of 10. The next concept we're going to talk about, we kind of alluded to a little bit in the previous section, but now we're going to be using the vertical line test. And the vertical line test is a test that you will use to determine if an equation or a graph is an actual function. Remember, the definition of function is, does every x value have exactly one y value? So if I look at the graph, so I've already put this into the graphing calculator. I invite you to pause the video, take the time to graph this on your x and y axis before we continue. Okay, so now that you've got the graph, if you were to take a look and ask the question, does this pass the vertical line test, go through and draw some vertical lines on your graph and see if it touches the graph in more than one spot. And notice that each of these vertical lines are touching the graph in exactly one spot. So therefore, because it passes the vertical line test, we can say that this equation is a function. The other thing that I could do is I could, plug x and y values in here and see if I'm getting one for every x value that I plug in, do I get only one y value? That's one way of doing it. It's a much longer way, and it's a little bit more complicated, I think, than just using the vertical line test. So remember, easiest test to see if something is a function or not is to look at the graph and do the vertical line test. So I've got 3 graphs here. I'm going to ask that you pause the video here in just a moment and try to do the vertical line test on all 3 of these. Then play the video to check to see if your answers compare to what my answers are. So again, pause the video now and then press play to check to see if your answers are the same as mine. Alright, so if you've paused the video, these are the following answers that you should get. This would not be a function because it fails the vertical line test. This graph would be a function because it passes the vertical line test. And this graph would not be a function because it fails the vertical line test. So hopefully you were able to get those same answers as I did. Alright, another concept that's in this section of notes is the concept of looking at an equation, or more specifically a graph, because I don't have the equation for this graph, and answering the question, where is this function increasing and where is it decreasing? So when we do this, we must always use the x-coordinates as our labeling mechanism to determine where it's increasing and decreasing. And that is confusing for a lot of students. So make sure that you're only using x values. So I'm never going to be looking off of this y value. I'm always going to be looking at the x-axis. So, and the other thing is you want to start from the furthest most left side of the graph. So for us, that would be right here. So this x value is -3. So at an x value of -3, our graph is going down. So therefore, at -3, our graph is decreasing. And it stays decreasing until it gets to an x value of this x value right here, which is -2. So from -3 to -2, our graph is decreasing. And where this is confusing to students is this looks like an xy coordinate. It's not. This is an x and this is an x. So understand that this is not an xy coordinate. This is from this x value to this x value, our graph is decreasing. Then what happens is our graph stays at the same stays at the same rate here. So it's horizontal, so it's constant. So from this x value of -2 over to this x value of a +1, it's staying the same. So we'd say from -2 to 1, our graph is constant. And then at an x value of 1, it's starting to increase again. And it increases until it gets to the x value of 4. So we would say from 1 to 4, our graph is increasing. Notice that all of these values that I have here are the y values. Excuse me, the x values, not the y values. The x values. I never looked at the graph at all here and used the y values. So it's important that you make sure that you're only using the x values, not y values. And then again, this is not a coordinate point. But it looks just like the way we write a coordinate point, so we have to, keep that distinction on this, that this is not a coordinate point. It's from this x value to this x value. And then the graph changes direction and goes in a constant rate, or a constant flow here, and then it changes to increasing. Now, not every graph is going to be increasing, decreasing, and constant. Sometimes the graph is just going to be constantly decreasing or constantly increasing. And it may never be constant at all. So you don't have to fill in all 3 parts, except for this graph actually shows all 3. It goes down, stays the same, and then goes back up.